Sorry, not first line. What? I don't know if anybody is feeling. No, lot of light, but I don't know if anybody is feeling hot. Should I close it? Yeah. Okay. I think you have a mic.
Okay. So welcome to the seminar room here. And we are going to have today a special meeting, or I would say on a special topic. Anxiety Wali, which has been with us during this year under the contract of the Balearic government on SOIP, is going to give us a talk to ask for your collaboration in bringing your research to the web in a nice form that can be used in an interactive way. Okay, so Akshay, please.
Okay. Thank you. Today I will talk about bringing your research papers to web and making them interactive and all that sort of stuff. So let me start. First, what do? I work under the supervision of Dr. Pericolet. I think not many people know what I do. They just know me like a guy who just walks around. So I do some work here. My job is to create visual web applications out of your research topics or research papers. Recently, we have converted, where is Maria? Maria is here? No, she's not. Her paper into a web application, and it's on the grids of electricity grids. And recently, we also started another project, which will be, visualizing Posidonia growth in web applications. So overall, what I will be talking about will be, of course, the visualizations of your research paper through web application, the importance of these things, the advantages which you get, how the overall rough structures of these web applications, how do they work, including I'll show you the use case, one case study, which the one which we converted recently, and the future possibility, like what are the things which you can do with these things. So usually when we start common visualizations, which are the things which you put in your research paper, like pictures and all that stuff, their job is to, and of all people, I don't need to tell you all, but still, They take a complex thing like this equation and they convert it into something much more visual and easy to understand. I mean, that still looks awful, but much better than the dreadful one. And they also can help you detect patterns and trends which you may miss in the regular format. It's much more easier to find things there rather than there, or maybe some people may disagree. However, these static visualizations, they have certain limitations. What are these limitations? And so enter dynamic visualizations, and these limitations are covered by these dynamic visualizations. Which, first, what if those visualizations which you had, they were interactive? You could tweak them, you could do certain things into them, you could, because the visualization which you provide are static. If you want to change certain parameters or something, you will have to again run your code or something. Here you can do it on the go. You just change one parameter, you have your things online. They're engaging, they're much more engaging. And I'll give you this example that they allow for people to do more tweaking. The more tweaking you do, the more edge cases you have in your application, the more mistakes you can find in your application, and you can make it better. It can include real-time data. If your application has some dependency on real-time data, you can include that here. They're platform independent. If you're running a code, you want to give it to somebody else, you need for them to download all the libraries which you have. You need for them to download all the Python version which you have, all those things, and then they will be able to visualize or run your code. This doesn't happen here because everything runs in the server and all the things are installed there. So they just have to open a link. They just have to have a browser or and a VPN from or an internet connection, which is, I think everybody has that. They're accessible from everywhere. You can do it from your laptop, from your phone, from your research paper will be available if somebody is sitting in a metro and they want to look at your research. You are able to reach much broader audience, much more broader than the normal static visualizations, because here you can give it to people who don't even understand your scientific research or the equations. For example, I'm working on that electricity grid and I have no idea what those partial differential equations do, but I still can visualize that stuff. So you can give it to people, laymen, normal people. It's very great for dissemination. If you are going for, I mean, usually people ask for funding. If you're going for policymakers or bureaucrats, they don't understand science, but you can give these things to them and they will be impressed. At this point is not that relevant to our use case, because in any way, academia, most of the people, they open source their code. But in some case, if you have some important code, you don't want it to show to anyone. The code lives in the server, so you can have a secure and safe code. So this is quite horrible because I'm taking a picture from the research paper. So and this was the static page. So look how damp and dull it looks. And look, and look what we did with the amazing job we did of making it more interactive and engaging. Sorry, Maria. So this is the paper I was talking about. This is what our use case is based on, and the web application. Now I'll show you the Joule. So this is the web application. You go there. The left-hand side is dedicated to all the parameters of the model. The center is the map, and the right-hand side is reserved for the graphs. You go there, you choose a grid. Only grid is Gran Canaria right now. We are planning to have more grids. So this is, I'll just zoom in because otherwise it's difficult to see from that angle. So this is an actual map. You can zoom in, see real locations. I don't know if somebody's from Gran Canaria here, but you can see those places. Let me just, yes, now it's better. So now you see all these red points are the power plants. The green ones are renewables, and the lines are the lines which are set up between these 2 points. So the lines, if you click on that line, it shows you a line is identified by a line number, that how many ohms of the Is it impedance? Z? Okay, sorry. That's what happens when I work with research. I don't know about these things. So the voltage, I know only JavaScript. So voltage and impedance between these two lines. And this just shows the dashed line just shows that the line is set up between. Right now, the electricity is not flowing between these two lines. So you go here, you tell the model that I want a simulation between 6 from 7 January 6 to, let's do 9, okay, 6 to 9:55, or approximately 4 hours. You request to the server where the model is sitting. The model will do the calculation and give you back the results. The results are, it will give you back the result for 4 hours with 5 minutes of interval. So each 5 minutes you get one frame, and like values for each and every line, what kind of electricity, what is the power flow, and everything happens there. So if you want to play that picture as a video, because you have at every 5 minutes you have a picture, you want to play it as a video, you can play it, and you will see from orange this thing will turn to red, because from 6 o'clock to 9:55 the energy demand is high. In fact, you can go there and change the FPS to maybe 30. You'll see more fluid. Yeah, so it does change. You can go to each and every node now, because these are sequences of 5 minutes. Every 5 minutes you have something. You can go to the node, click there, and you can see that how this particular power plant, the frequency and the generation varied throughout the map. So the graphs are just one click away. You can zoom into the graph. It took me a long time, so I'm just showing you. And then when you double click on it, it goes to the normal. You can also do that with the lines. So for example, if you say that I want to know that if I go to this particular frame, which is 8.5, this color, how much was the power? You can go to 8.5. Yeah, so 190 megawatts was the power. Now you can do all this with the graphs and everything, and these are also interactive. Next thing you want to do is you want to know how the dynamics of this grid would change if you would remove a line, open a line, or add a line. So if you, for example, say, let me open a line, so it'll say click on the line, you'll click on that line, and you'll say yes, confirm that I want to open that line. This line will be open because this is the main line which is connecting the two biggest populations. So it'll be amazing to see if what happens if that line fails. I can also add a line, and if I click on add a line, it says click on the starting node and then click on the ending node. And then these are the values which every line has. I'll just set them to default values and confirm that yes, I want to add a value. And then I want that model to continue the simulation from where it left the last time. So I will say that rather than initializing your default values, whatever you do, continue from the last time. And the last time was 9:55. And let's I don't know, you can do it to more 4 hours, 12:55. And if you send a request, it should return it. This line should vanish, and there should be a new line here. And you can play the simulation again, and since this line is gone, all the load is on this particular line. So now this line shares the load, and you can see how this line evolves, or this place generates, or let's see if renewable, yeah, there are generations of stuff. So you can do all these things and add, remove lines and all that stuff, and see how the model evolves. Right now, when we started this, we envisioned that our final goal was having these many functionalities. And since we already have it, we said that, okay, we should do a talk about it. But it's not just this, we have more plans. We were planning to visualize how blackouts happen. You could predict in future what will happen one day after if you have the data till now. And some more things. We were planning to add Balearic Island as the things. So there are more things, and this is available. This is online. So if you want to go and play around, I don't know why you would want to do that, but anyway, you can do that. You just need to be connected to EFS VPN and just this URL, and you can go and have a look. So this was the web application, one case study, and a recent new project, which was we started because this was almost done, and then we can take our time to add new functionalities. We started to thought of starting something new, which was to visualize this Posidonia growth in making a web application for this. So you just give some parameters, and then you can visualize this thing. So that's one new thing. There's nothing substantial which has been done for this. There's just ideas, but I think in few weeks we will have something which you can show you. Now I'll go back to whatever you saw there. I'll just go back and tell you how a very rough sketch how these things they work. So you have a front end. Front end is a very fancy name for a browser, and in that browser you type the address of the URL, which was this. So if I reload it, this is the browser. This is the address. You type it, and a request goes to the backend. Backend is another fancy name for Nuraduna server. It is a CPU there. And so as soon as you enter that, a request has gone to Nuraduna, or not Nuraduna, but whatever CPU is there. And then the backend returns a bunch of JavaScript files, code files. These files, the function of these files is to tell the browser that how will you draw a box, how will you draw a button, how will you draw lines or nodes or something like that. So as soon as you pressed enter, a request went there, and the server sent back some JavaScript file, and that JavaScript file, those JavaScript files told the browser that, hey, draw a box here, draw another map here, power grid here, or things like that. So it sends back those JavaScript files. So now you have your framework, your blueprint, what do you want to do. Next you'll do is you'll make a request to the backend to run the model. So now this is the second request which you make. So you select Gran Canaria, you select all the parameters, and now you make another request again to the backend. So once you make that request, the backend goes, because we have a dependency on data, our model, it requires data. So we also need to have a database. Our model goes to the backend and then accesses that database. That database, it retrieves the data, whatever it needs, and then prepares the JSON file. It retrieves the data, feeds it into the model runs and saves the results in a JSON file in the backend. So everything, what is happening is in the backend. Then that backend will return back the JSON. So here, the first request, JavaScript files came in, you drew, everything was drawn. You select your parameters, you send a request, goes to database, collects back, saves the results in JSON file, sends back the JSON file. That JSON file is sent back to the front end. The front end takes that JSON file, and in that JSON file is the information which line to draw where and what color should that line be. So that, and how to draw all that stuff from that JSON file is, that information is in the JavaScript files which was sent the first time you access the server. So not only it helps you to draw these buttons, those JavaScript files, it also helps you to how to parse that JSON file, because you have the information now. How to convert that information into animations is in the JSON file. So I think there are two takeaways, that the animation which you see, all these things, the green, blue, no, there's no blue, the green, red, orange, all these lines, oh, there's a blue node, all these things, they happen in the front end, which means they happen in your browser. Your browser is on your laptop, they happen on your laptop. So you are computing all these. So all the load is taken by you, but the model computation happen at the back end. So whatever this model computed, all the partial differential equations and all that stuff, that happened on the server. So you don't have to worry about all those things. And this is important in knowing what are the benefits or the cons or the limitations of this system. I'll explain you later why, but so this is how this works. I would like to show you what few things which are possible, which I would show you, and there are many more things which are possible. And by the way, any questions? No. So one example would be a fluid fluid simulation. This is a very simple, it's more like a wallpaper on browser, but this is an example what you can do. These kind of animations you can do if you have some fluid simulation. So you just click there and whoa, no. So you can do such things. This looks quite real, and it doesn't take much computational power to do on your computer, but so you can do all these things. The second one was, this is the website which draws chaotic attractors, different kind of chaotic attractors based on the parameters, but that website is down for some reason, so I'll show you a YouTube video. So I don't know why somebody would do that, but this is a chaotic attractor, and on top of that, somebody's drawing some tree-like a structure, but you can do all that stuff. It's very high computation, but people do it. So whatever. So the structures are growing on not very exciting at one speed. But the example is that you can do all that stuff. It's very, because what you see is the light is coming from that angle, and if you see there are shadows here. So these are the things which are called as ray tracing. To make it more realistic, because in real world, when you interact and see things are not just plain objects. The light bounces off, and that gives it the texture and the realistic things. So you have to like literally there are rays of light, the vectors, and then you have to compute how they will bounce off. And to give it real texture, you have to compute all that stuff, and that's super compute heavy. And that's why you see here that it says DLA 3D GPU. So all these things are calculated on GPU, but you can also do those things on a CPU, but it will run a little slower. And you can do many more things. If you can do these things, then other things are also possible. Backend possibilities. This was the front end. I told you that all the animations have to happen on your front end. So those were the possibilities for the front end. For the back end, if you have a model which uses parallel processing on GPUs, which is the case for Poseidonia project, we are planning to do that in the back end for the GPUs. You can do that. Buffered data transfer. Okay. So if you go back here, and if I send a request again, you see this it takes some time for the model to prepare all the things. And this is just for like 1 hour, hardly 1 hour. If I do it for 14, if I send a request, now request has gone back to the server, and it's running the model. It takes a lot of time, and you're doing nothing in that time. So what happens, the model is preparing stuff, but then it will store into a JSON file. When that whole JSON file will be prepared, that's when the model will get over. Then and then only you'll get access to all the data. But instead, what you can do is, because model is running and it's creating and it's calculating stuff sequentially, the moment it creates the first frame, it sends back you the first frame. That is called as the second frame and the third frame. So you can start seeing stuff even though the model has not finished calculating everything. So that kind of stuff you can do with buffer data transfer, and it's quite amazing how much it eases the user's experience. You can run deep learning models and more compute hungry algorithms, which is just the same as the first point, but just to increase points, I think you would. Real-time data crunching. Yes, if you have some, for example, if you're doing something, for example, in our case, we don't do real-time data crunching. But if you have dependence on data which is actually real time, some people, for example, there are applications which deal with stocks. I don't think we will do that. But if you have that, you can literally do that, because a WebSocket can have a real-time connection. This is real-time interactive server-side rendering. This is a long pill. You see here, I told you this runs on GPU. So what happened? And this is interactive. You can take your pointer, click in some point, rotate it, and then it will shift. But then the problem is, as soon as you rotate it, it'll have to calculate everything again, because now you want to see how it looks from the other side. It'll calculate how the light bounces off and blah, 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 blah stuff. So in these cases, when it's so compute heavy that your browser or your CPU cannot do those things, this thing comes in, real-time interactive server-side rendering. So as soon as you click on that place and you try to move it, the whole screenshot of the screen and the information that where you clicked and which direction you're moving to will be sent to server. And then server will say, okay, this is the screenshot, this is the place this person wants to move this object to. The server calculates everything for you and sends back the next frame, and then you see the next frame. So there's a direct connection or conversation happening between front end and back end. So which means that even if it's too heavy, it can be done. It's a little difficult, but it can be done. Yep, so we are looking for ideas and papers to be made into web applications. So if you guys have some projects or things which you would love to visualize, we would love to hear from your ideas. And even if it's difficult, we love challenges. And but anyway, if nobody has noticed, that's Clint Eastwood in lab code, and that I think is pretty cool. So how can we proceed? How does the procedure goes on? So first you come to us. We don't come to you. You come to us. Discuss a suitable. No. Oh, okay. Yes. Oh, I forgot. Oh, sorry. This is the first step. Okay. So discuss a suitable visualization schema for your research topic. So we will discuss like what kind of animation do you want? Do you want those hardcore, realistic looking 3D animations, or you're okay with some cheap Nintendo-like animation? Discuss your model, its input, its output, what are the data dependency, computational power. So first you decide what kind of front-end schema you need. Then you decide what kind of back-end things you would need. Then decision on the web app framework. This is quite technical stuff, like what kind of language do you want to use, because your model will be made into some language if it's compatible with. So you can discuss all that stuff. And then our job starts. We will implement the front end with some mock files, which means you'll just give us the output. That output looks like this, and then we will implement the front end for that particular output. And then we'll develop the backend and the database if needed. And then we'll connect all these things together and put it on the VPN or something. And then we will test it, of course. And this is quite important. Then there'll be continuous versioning. So when I told you about this app, I told you that there are more things which we want to do it. So let me show you this. If you see the URL, that's my local computer. That's my laptop, and this is in the VPN. This is the server. So what happens is, as soon as somebody tells me I need more things in this project, I go back. I don't touch the server, the code. I go and do stuff in my local computer, and then when the people are satisfied, then we go and make changes. So that's how the versioning things they happen. For example, here there was a new requirement that every 2 node will, right now they only have a single line between them. What if they have multiple lines? So if you select so right again. Okay, so if you see now there are multiple lines, so the lines are actually curved. These are new things which you implement. And then if you send a request, the flow in the previous one was shown by an arrow, but here the flow will be shown by the moving line. So you can clearly see that but this makes the fan of your PC go haywire because it's quite computationally intensive. So in 1 minute, I can hear my fan. It's not good. So this is how the versioning works. And one last thing, which I wanted to show you, was on emphasizing the fact that how these things can help you in not only finding edge cases in your model, just the fact that you have visualized it in an empirical way. So if you open this particular line, say, okay, open this line, and if you add another line, I don't think it'll make any difference if I add a line here, but anyways. And then you send a request, this should vanish, there should be a new line. Now let's try to do another thing. Let's try to open this line and press confirm that we want to open this line. This line is special because as soon as you do that, the network gets divided into two networks. And if I send a request again, this side should vanish, but it did not. It turns out, okay, I don't know what, because there's this thing in the model. So I will say something, it may not be right. There is some kind of matrix in the model. As soon as you do that, that turns into some singular matrix. So when you do that, that's a big no-no for the model, that you cannot do that. So the model has a glitch. Of course, the people who made the code, they knew that there will be it. So they put an error that as soon as the singular matrix, you get in singular matrix, you should get an error. But this edge case was not in that file, that when you dissociate the network into two and then remove this file without, and if you see, I did not do continue from here. So if you do in a non-continuous way, if you split it, then you get, that's a glitch. So a visualization in this case, the point I'm trying to make, pushed you to find, because it was much more engaging, you did more things rather than going to your IPynb file and changing one parameter in 3045 line and then coming back and then running all the notebooks. It pushed you to do more things, and then you found a specific case, an edge case, which most probably you wouldn't have found in the code or something. So this is also useful for such extravagant things. And only blue steps require your participation as a researcher, and other things will be handled by us. And I need 1, 2, 3, 8. Oh, you require more things than us. So, yep, thank you. Questions? Yes.
I have two questions actually. One, the first one is how, I mean, the design because that for the power group, how modular is it in the sense? How modular is this design in the sense that if I have now my problem, for instance, the Posidonia problem, what can be reused, let's say, and what has to be written completely from scratch? Is mostly, I mean, you need to program everything, or you can reuse
we can
a lot of
reuse
stuff.
your code, whatever your model code.
Okay, my model.
Code.
No, but regarding the dashboard, let's say the graphical platform.
All those things are completely.
How much is modular?
Oh, sorry. All those things are completely reusable. For example,
Not just clean.
Yeah, just clean. Yeah. If you go here, you can just replace all these things and put your parameters on the left-hand side. So that's what the point which when we were talking about Posidonia, we said that we already have everything built in, the backend and everything. We just have to change it. But then we decided that because they have this GPU requirement, maybe we need to change some language, or if your visualizations are heavy, then rather than using frameworks like JavaScript or something, we can now use WebAssembly or Rust. These are kind of things. Okay, my second question, sorry, is how about 3D graphics? I mean, here everything is 2D, but as you know, for instance, in the example you show, 3D graphics are not trivial. I mean, no. Is Eva here? No, because she has a lot of 3D stuff. No, it can be done. There's this thing called as, if you see GL, that's the library WebGL. It's used for making 3D graphics. The only thing is we'll have to figure out a way how heavy do you want those 3D graphics? Do you want them realistic? Do you want them? But this thing, this
YouTube that you're showing here, you have not done it. I mean,
No, we have not done, but it can be done.
but there's you say there is some library, this thing that you can use
Yeah.
for 3D
Yeah.
graphics. Okay,
Yeah.
thank you. We can discuss more.
I have a curiosity. You said that whoever has the access to the VPN can go and play with the thing. Do you plan on publishing it more open, like to the whole community, not just the IFIS? Okay, this.
Yeah. So my question was, what are the tools to make these things? I mean, because right now I think by what I understood from your presentation, we are a bit depending on you, Akshay. So
Yes.
is there a way for us other mortals and simpletons who use Python to maybe, I don't know, is there some other more accessible tools? That would be interesting if you could also, if you happen to know them, to cover them for another talk or something.
Yeah, I mean, yeah, sure. I mean, but that's like taking my job. So no. But I mean, you can do all that stuff, but there are some. Yeah, I can do one talk on that. That what are the specific things which you require for making? So if everybody can do their own stuff, and then bye Akshay. So no, we can do one talk on what are the things which in much more detail rather than this, that what are the frameworks which are required for the front end, what are the things which you require for back end, how do you connect all these things together and all that stuff.
I see you absorbing the scientific spirit of sharing knowledge.
Yeah.
Well, it's just a comment on Jesus' question, is that there is this like something called Jupyter Books, which like you create from a Jupyter notebook web page, which is also interactive. And I think that you can also insert JavaScript code and for sure animated plots there. I don't know how those plots are created, if they are GIFs or they are run on actual Python code, but it's something that it is quite modular and you can already create a web app from a notebook that already exists. So it's a possibility for you to explore also.
Okay, I didn't know about that, so maybe I can go and look.
Yeah, but the plots are interactive, so
Hi. Yes. You say that you are using JSON files to interchange that data. You say you are also using JavaScript files to tell the browser what to do. You already say that for intensive applications, and JavaScript could be, it's better to replace it by something like GL or some other thing. But about JSON, I am not sure, but as far as I understand, JSON are text files.
Yeah.
And I guess that for some applications which can be that intensive, for example, the fluid dynamics you have shown, probably text files will be not suitable. You need something binary. You think it's easy to change? It's just changing the format of the interchanging file, or do you need to do some real restructuring of your thing to make interchange between backend and front end in binary, as a flow of binary data?
Well, right now, how you save a JSON file, because as you said, it's not that huge. Once it gets huge, it's a pain to send them. So right now, what happens is that JSON files get saved in the backend. You make an HTTP request, which means you have a connection with the front end, and then you send that JSON file, right? There's another way which are called as WebSockets. So you continuously establish a connection, and then you keep sending data to it. You keep sending data. As soon as the data is formed in the backend, you keep sending it in the front end. So you can look at the data in real time. So it's not that heavy. And for example, in online gaming and all that stuff, they render huge 3D graphics, and then they use these techniques that they send data continuously. So with fluid dynamics and all that stuff, the dynamical things which I shown you, that can run in your laptop in front end. So it's only when the things get really, really high computationally heavy, you need those things. But it can be done. And by the way, JSON is still, I mean, part of JavaScript because its full form is JavaScript Object Notation, JSON. So, anyways.
Just a curiosity, do you use a sort of container in the server in order to, like Docker or Portainer, don't know what, in order to let it run? Yeah. So that's the question. Have you ever think about creating a sort of development container and I don't know, production container,
We
possibly,
have
or a test one?
In my
Yeah, because
local
in that way you don't have to use your localhost in order to let the people prove
Yeah.
the stuff. So you just have to open the door on that that particular container, and you can get free of using your localhost in order to show stuff, or I don't know what, and it's more safer, more with the container. So you have it, okay?
Yeah, I'm on the same page.
Yeah, okay, but actually the database you can let leave the database actually over on the server. There's no problem. The fact of using the container is just to create 3 different situations, which you have the testing, the developing, and the stuff. But yeah. And for deployment, you use it to something in particular, like Portainer, or you just use a Docker container?
It's just simple Docker Compose containers.
Just simple.
I mean, it's a dirty way. You can do much more sophisticated things, but yeah.
Thank you.
So much more general, if we want you to create something for us or the stuff, what are the good things that we should do to prepare our data or model? I mean, it's better with some programming language in a specific. The data is better if it's a database instead of some list or.
Well, I think everything can be done according to your need. For example, the backend doesn't have any specific requirement that your code should be in Python or in Julia or in some other. I mean, Fortran, I have not done that, but I'm pretty sure that I could run Julia, Python, and all these codes. But not any particular requirement from our side. We can adjust to your needs. Because at the end, you'll have to make the model, and the models are heavy. For example, most of the models are sequential. So it's much better to give the freedom to you that you can make model in whatever whatever language you want, and then we can do stuff.
So most of it, like the fast thing that happens is if the model is better code.
Yeah, exactly. Because here the bottleneck is the model, because model takes a long time.
Okay.
Are you going to make the repositories of the code you developed available internally?
About that, I am not sure. I think I'll have to ask these people. If they say make it public, I'll make it public. Right now, it's not public, it's private.
Okay, thanks.
Any more questions? No questions. Okay.